Hello. Thank you for joining us for today's Corringo Tech Tuesday webinar. This session's topic is Best Practices for Object Storage, Installation, and Management. I'm Ryan Meek, Principal Solutions Architect at Corringo. Before we start, a little bit of housekeeping. Don't miss our upcoming events. February 27th, Brews and Bites webcast, Episode 2, on economical storage options, and March 24th, Tech Tuesday webinar, Managing Data in HPC and Research Environments. For today's webinar, I'll be your host, and our subject matter expert will be Jose Marcos. We'll be available to answer your questions throughout the webinar and at the end of today's presentation. In addition, we have several resources available via the Attachments and Links tab on your view screen. If you have any questions after the webinar, you can always reach us by email at info@corringo.com. I've introduced myself. And Jose, why don't you introduce yourself?
Yeah, for sure. So, hello everyone. I'm Jose. I've been with Corringo since 2015. I'm actually originally from Spain, so sorry about my accent. I do my best, but I live in Canada now. I actually work with our customers here in Canada, as well as in Latin America and the US. My role in Corringo is to help with proof of concepts, answer technical questions, and also integrate or work with our partners to integrate their solutions with Corringo Swarm, our object storage platform. Back to you, Ryan.
Jose is an absolute expert, so we're in good hands. So about Corringo. Corringo was founded in 2005 to change the economics of data storage by enabling relentless data growth. Today, Corringo software-defined object storage solutions are used across many industries by organizations such as the U.S. Department of Defense, the Department of Justice, National Institutes of Health, Argonne National Labs, British Telecom, NEP, Rutherford Appleton Labs, the Brazilian federal court systems, and hundreds more worldwide. Jose himself has been instrumental in many of those installations. So without too much delay, we will get right into it. And we're having a bit of a difficulty through our system. So we're going to stick with it and get you to the next slide as soon as we can.
Yeah, I think we're going too far right now, so let's go back a little bit.
Go ahead.
Are you seeing the overview?
Go ahead and take control of the slides if you can, Jose.
Yeah, let's do that. I think we're clicking at the same time, probably. Yeah, so yeah, let's move a little bit forward. So yeah, I think the first thing that you have to consider when you are planning to get or to build a new object storage platform is actually networking, and it's something that sometimes is keeping, it's keeping away from our fingers so far, or having issues with the networking that we haven't planned to, right? So it's one of the most important things to consider when you are planning object storage networking. Object storage the platform deployment. We actually recommend to plan for a multi-layer deployment, having the storage cluster nodes placed in its own VLAN or switch, and the clients being on their respective client networks. We will talk a little bit more about it later during this presentation. Also, the other thing that you want to consider is if you want to have some sort of traffic aggregation, for instance, like as simple as, maybe not traffic aggregation, but just as simple as a failover mechanism, whereby if you have a broken switch or a switch goes down for any reason, you will be able to continue to provide service to your clients and applications. The other thing that you want to have to increase the throughput of your object storage is some sort of bonding mechanism that may basically have like a teaming on the network side, so at least have a couple of ports aggregating traffic between them. If even better, if you can use LACP as a way to do that traffic aggregation and to get the most of your networking devices. Also, IP assignments are key. Sometimes we start a deployment and, okay, what kind of the IP address should be, configured for the object storage cluster, or how my clients will be accessing the object storage. How many hops do I have to go between my client application and the actual object storage platform, right? So it's important that you have all of this in mind when you are planning for on the networking side. And of course, in the end, just get a diagram, just draw a diagram of the deployment that you plan to do, right? So it will help to clarify all these things and to see more clearly what is the data flow that you want to follow, right? So in that sense, you have also the namespace in consideration as well. Think that object storage in the end uses HTTP. It doesn't matter if you are using plain HTTP to access the object storage platform, or you are using S3 or Swift. In the end, those are HTTP calls in the very basic level, right? So it means that you have to plan your naming conventions. So, for instance, something as, archive.mycompany.com, right? Or projects.mycompany.com. Something that will help you to actually align the resources or the use case that you have for this object storage platform with your applications, with your workflows in the end, right? So everything must be aligned. So the name that you use you must be able to create a DNS entry that points that name into an IP address. And also, if you are going to use HTTPS, HTTP over SSL, TLS type of communication, you want to make sure that you have to create the proper SSL certificate, right, for that specific name that you want to use. Like I said, archive.mycompany.com, objectstorage.mycompany.com, or even multiple, levels of naming there, like projects.delivery.mycompany.com or something like that, right? So it can be as complicated as you wish or as simple as you wish, but just make sure that you are that you have all of these concepts in mind. The naming conventions are important.
I think I would point out here too, using fully qualified domain names, doesn't it really provide a worldwide namespace?
Yeah, for sure, and that's why it's important that everything is aligned with the workflows that you want to have, right? So, for instance, you may want to have kind of East Coast, West Coast type of approach that have east.storage.mycompany.com, west.storage.mycompany.com on each of these levels, and have like a global namespace that only is storage.mycompany.com, and have some sort of intelligence layer there, like a load balancer, for instance, that basically routes the queries from the clients depending on which one is closer to the client, right? So that falls down into, like I said, planning into name conventions is something that is we have seen in the past that some customers doesn't really spend too much time on thinking about what is the name that I should put to my cluster or to my object storage platform, right? With kind of DNS entry should I create. So that's something that we actually recommend to just think about it very carefully and then just implement that names and everything. So it will take like probably half an hour or something like that to think about all of this, and then once you have it, just plan to do that and deploy that way. If that makes sense. So I will move on to the next one. So we have now our kind of our IP address in place, we have our names in place, but we are going to need probably some sort of authentication and authorization mechanisms, right? So to be able, for instance, to that a user is able to get to the specific contents with the appropriate permissions, right? So in that sense, the next thing that comes to mind is where I'm going to store my users. I'm going to use an LDAP server. I'm going to use Active Directory. Perhaps it's just local users on a PAM Linux system, right? Or even I can just go further and use tokens to authenticate all the operations that are happening to the object storage platform, right? So that's something that needs to be, planned as well. And we obviously recommend to have a proper identity management system, a centralized one, or that you can just create the users there or the groups there and use that to integrate with your applications and even your actual clients or your actual users, just logging with specific credentials that are able to join to get to the cluster and do the actions that they are granted to. So in that sense, you also have to think on what are the multi-tenancy features that your object storage platform provides, right? So there are so many solutions in the market, and there are many different approaches, right? So many of them just allow you to create buckets, for instance, right? And set permissions perhaps only on the object level and not on the bucket level, or not on the endpoint per se. So all of this affects to the way that you have to plan when you are planning to deploy an actual object storage system, right? What are the capabilities of the multi-tenancy features that my object storage solution will provide? So in Corringo, for instance, we have 3 levels. That's the tenant level. Domain is like the endpoint. So, and then you have the bucket level as well. And of course, the object per se. So you can set ACLs, you can set permissions on each of these levels. So I think that's an important feature. You may want to use it or may not need it, right? But on the multi-tenancy side, just to have these features on a way that you have like a structured policy that makes sense from the tenant side up to the object side, and I think that's quite important, just to make sure that the appropriate users or groups are able to do the actions that you want to allow them to do, right? For instance, you may want to have a specific group of users that is able to upload and download, but not to delete anything on a specific bucket. So you should be able to have that kind of faculty in your system, right? So yeah, in that sense, the next step will be, okay, I will have roughly a rough idea of what kind of permissions, domains, and buckets I would like to create, and the names and IPs and everything. And also, but the next thing is which clients will be used to access the object storage. For instance, I am going to use an application that supports, for instance, the S3 protocol, and then just use it to move data. I don't know, I can think of an HSM tool or a backup tool like Vim, Commvault, Impana. Any of these guys support the S3 protocol out of the box, so you can use them and just point them to store your backups to your object storage platform instead of storing them into a tape, right? And the same goes with media asset management in the media and entertainment industry. So we have seen that more and more MAMs support the S3 protocol, not only in the media and entertainment sector, but in many other verticals, that S3 is kind of becoming a standard in the object storage world. So what will be, the point is, what will be the protocols that I want or I need to use to communicate with my storage? And perhaps, and that's the last point that you have there, I have to have like a specific application that does the ingest data using the NFS protocol, and I have then my client application that reads that data back using S3 or HTTP. It's my solution, it's my object storage platform being able to provide a universal namespace, meaning that I have the possibility to access the packet over NFS as well as S3, right? So I think it's kind of really important to just to make sure that you have all of that in place.
So you're saying with some systems you can access the same buckets and the same namespace over S3 and NFS at the same time using their own authentication mechanisms, but some systems just don't support that.
Yeah, absolutely. That's something, for instance, that Corringo Swarm does. So we have the ability to have this universal namespace. In the end, you're accessing the same namespace, but using a different protocol. All of them have their own benefits, and but it's just basically related to the type of the workload or the data flow that you have in your environment, right?
I guess what you really want to avoid is just a different data silo for every protocol.
Yeah, for sure. Yeah, that's true. Yes, I think having the universal namespace enables you to have or to provide much more integrated solution for everyone, right? And especially if you have a very large cluster and you don't want to have silos on a cluster, right?
Mm-hmm.
Okay, let's move on to the storage cluster best practices. So now we are talking about the actual storage node that we have behind the scene storing your data. So in that regard, especially if you are going with a software-defined storage solution approach, you just basically need to account what type of performance requirements do I have, if I have any, right? So that's kind of the high-density servers versus low-density servers type of deal, right? So I can give you just a couple of examples to illustrate this. We have customers that use our object storage solution as kind of cold archive, deep archive, if you wish, and they would like to go with 60 drives for you type of chassis, so they can store dozens of petabytes of data on a very small footprint on the data center, right? So for those scenarios, perhaps you go with, like I said, 60 drives, 45 drives per server. While if you want to get some performance out of the cluster, you will need to go with a low density approach. That will be 12 disk drives on a 1U, 2U chassis type of deal. So in object storage, when it comes to performance, it's basically about the ratio between the number of disk drives and the number of cores that you have in the machine, right? So for instance, if I go in with the deep archive scenario, perhaps I have like 20 cores for 60 disk drives, right? Whereby if I'm doing kind of a high performance one for high performance computing, for basically video streaming, could be another example of that kind of scenario. I would probably go with kind of 12 disks and 12 core. So one disk, one core type of ratio there. So that's something that, again, just needs to think about it. The next one will be how many objects do I want to, or do I need to store? It is something, I am storing like 1 billion objects in 100 terabyte, or I am storing like very, very large objects, like 100 gigabyte object, or even terabyte size objects in my object storage platform. That's something that affects a lot the type of the sizing that you have to put in place regarding the storage nodes. In our system, for instance, what you will need to store a lot of very tiny objects is basically RAM, right? Also, it affects the regarding the the size of the files you can use, and we will see this just I think in a couple of slides after this one. Replication, erasure coding type of mechanisms to protect your data. So that also impacts the number of the amount of RAM that you have to have on the servers, on the object storage nodes. The next step will be to plan for maintenance and failure scenarios. What happens if I have to bring down a server to replace something on it? Or what happens if I want to go through a hardware renewal process where basically I'm taking out some old hardware and putting in place new ones, new servers, right? So even all the systems support this kind of recovery scenarios whereby you have a broken disk and you have to recover that, or the data needs to be recovered. There are many implementations that differ between different vendors. So just make sure that the protection scheme that you select matches the hardware that you have, right? For instance, if you have like 3 servers, don't go with a very aggressive erasure coding type of a scheme, because you will probably run out of disks to be able to maintain that kind of erasure coding. I'm talking about maybe 9.3 or something like that, and you have only 3 servers, right? So it doesn't make much sense to do that kind of erasure coding with a very small cluster. So these are the things that you have to keep in mind. And also have some kind of monitoring doing on your platform, right? So I want to get an alert or something if I have a broken disk or if a server goes down for any reason, right? And besides that, when I am scaling out my cluster, I have to have some kind of trend to be able to anticipate when am I going to need more disk space or more performance, right? Maybe my cluster is at 20% usage on the storage level, let's say on capacity, but it's like a 90% or 80% of the performance that it can deliver, right? So it's both. When we talk about capacity planning, it's not only storage per se, it's also performance, right? Just to make sure that everything aligns correctly.
I would note here too, we got a question from the audience. Do you anticipate or do you know of object systems that are instrumented with agents to log performance? Or, how can they hook into available kind of industry standard dashboards?
Yeah, sure. So I can tell you what we have in Swarm in our object storage platform. We have 2 different approaches, or actually 2 different ways of getting that information. One is using SNMP, so you can integrate with your monitoring tool just by using industry standard SNMP, and just query the cluster to see if everything is okay, or to receive alerts if something is not responding. And the other probably better way to do that is using Prometheus and Grafana. So we have integrated dashboards that we have in the product that basically shows you a Grafana dashboard with all the information that you need to know. And it can go very detailed. It can go even to what is the kind of the response time that I'm getting from the nodes when I'm doing my operations to the cluster, right? So
thanks for that.
Yeah, and also
I would note too. We love questions, so if you do have additional questions, please send them to us through the BrightTalk interface. Go ahead, Jose.
Yeah, I'm just wanted to say that we also have, in our case, we have a HTTP portal. We call it the Swarm UI, that you can just log into that portal and take a look to, to see if everything is in green, everything is fine, take a look to the logs and so on. So you can just actually log into some kind of portal that gives you that information directly from the cluster if you wish. So yeah, we talk about the integration with applications. Like I said before, S3 is becoming kind of the standard de facto for object storage. Well, as you probably know, S3 is a protocol that Amazon created for its own cloud and service, AWS. And like I said, it's something that we see that more and more different software supports now S3. So that's something that probably if you're going to use object storage, in the end there is a big chance that you are going to use the S3 protocol. A lot of vendors support the S3 protocol. It's not like Corringo supports S3 protocol. You have a bunch of options out there, but there are small differences on the way that we implement, or each of the vendors implement the S3 protocol from Amazon. Right. So, for instance, there are some the basic functionality that is the create, read, update, delete, and list that you have there. And object ACLs, that's something that all the vendors should support out of the box without any kind of plugins or wait for me to create or to develop something to be able to set object ACLs, right? But there are some differentiated features. That is, for instance, does my solution support object versioning? Object versioning is basically having multiple versions of the same object stored in the cluster, and have the ability to retrieve a specific version, or have the ability to delete a specific version if I wish, right? So does my object storage platform support object versioning? Does my object storage platform support multi-part upload? That is crucial, that is critical actually when you are dealing with large files. You can increase the performance you can go very high on performance just on throughput just by using multi-part uploads. Multi-part uploads is basically upload the file on chunks, on segments at the same time to the object storage. So instead of having like a single connection and just push a 1 GB file through a one connection to the object storage, you can create 10, 15 connections at the same time from the client and push that information, way more quickly than you would be doing with just a single pipe to the object storage. And also, there is another consideration that you may want to have in mind. There is it's called the AWS signatures, right? So there's the B2 and B4, version 2 and version 4, if you wish. That's kind of the way that the communication happens between the client and the S3 server. In S3, each of the HTTP requests must have like a specific format, and that's basically defined by the S3 version signature that you have. So V2, yeah, it's kind of the old one, if you wish, but it's actually the fastest in regards of performance. V4 introduces more redundancy, introduce more levels of security, if you wish, when you are communicating with the cluster, but also the performance is not as good as with V2, right? Because it's a little bit more complex. But again, it's something that you may want to take a look at. If you just open any S3 client, S3 browser, CyberDuck, and so on, you have the ability to select which kind of signatures do you want to use between V2, V4, and you can see the difference between them even in your own environment. Okay, moving on. Let's take a look to the S3 best practices. At the very beginning of this presentation, we talk about having like a dual network scenario where you have your clients connected to the productive client network that is already in place, perhaps, and having the storage nodes kind of on a separate VLAN, separate switches, maybe using traffic aggregation, LACP, and so on. But then how do I communicate between my client and the storage nodes in the backend? Well, we recommend to use a gateway, right? So that's the way that we actually implement this service in Swarm. So a gateway must be a scale-out, must have the scale-out models. So as well as you have on the storage nodes, be able to grow up to hundreds of petabytes, be able to grow up to thousands of nodes in the same cluster. The same goes with the gateway approach, right? So having this kind of scale-out type of architecture. and it must be a lightweight reverse proxy. And also, it's not there, but it is the best practice is that it cannot hold any state. It has to be a stateless piece of software. It means that if you lose the gateway for any reasons, your data is safe because it's already stored in the storage layer behind the scenes, right? The benefits of having kind of this gateway approach is that, well, you have more control, you have more security in your environment. Also, you have the ability to place in front of the gateways, you have the ability to place a load balancer that can do the kind of east-west that we discussed before, right, type of a scenario, or even to take care of doing the SSL offload, right? So you're not require much more resources on the gateway side. So because the load balancer will take care of enforcing that SSL offloading.
I would guess I would guess one of the reasons that so proxies or gateways are recommended here is so that customers can dynamically allocate resources and add more if they wish at runtime.
Yeah, that's the thing. Yeah, for sure, and that's the last point that you have there. And again, it's capacity planning. So the thing with the gateways, like we said, is stateless software, so that can scale out. So you can basically take a look to that. Maybe you are good with just 2 gateways on your environment, kind of for failover scenarios, or perhaps because you are a service provider and you have like 1,000 requests coming from a number of clients in your environment. Perhaps you want to have multiple gateways, right? So that's something that comes back to the capacity planning that we discussed.
I would also guess, and I guess I've seen directly, people will put gateways up to guarantee kind of a certain service level per customer or per bucket.
Yeah, precisely. Yeah, that's again capacity planning. Yeah. Okay, so how we can ensure the data integrity of our information, of our content, right? So this is kind of standard, if you wish, but I think that is worth to mention. Input validation, well, on the application level, just make sure that the content that your application is uploading makes sense before uploading it, right? The next one is data validation, data in transit. Just have the mechanisms to make sure that the data is not corrupted or is not modified in flight, right? So when it's traveling from the client to the server. Error detection is something that the object storage cluster should do. We obviously do that. It's just basically to make sure that have a health processor in the backend that makes sure that your data is safe, your data is not corrupted, checking for bit rot, things like that, as well as have the ability to detect when a disk is about to fail. Right? Instead of waiting until the disk is failed and then kind of rebuild the data, anticipate that failure scenario because your object storage platform is smart enough to detect that there has been some writing issues at some point to the disks. So it's a safe zone to assume that maybe this disk is kind of about to be broken or about to break. So that's something that it's very interesting and very important on the cluster level. Obviously, your clusters should have some sort of, like we discussed before, some sort of access policies and constraints. You must be able to set those kind of ACLs or permissions in multiple levels if you have multi-tenancy features on the product that you're using. Also, hashing. Hashing means that we call that integrity seals in our system. It's basically the ability to verify that information has not been tampered with. So let's say that your information, you upload a file and you go like 2 months later and you want to make sure that that specific file has not been altered since it was uploaded to the cluster. So that's where hashing becomes handy. Worm is kind of the next step. is just kind of the ability to lock that information so it cannot be deleted or it cannot be modified. Even if you have the proper permissions, if you try to modify a warm object, you should get an error saying do that. Okay, you cannot do that. Obviously, you cannot delete it and you cannot modify until a specific time comes. Like I upload something that cannot be modified for the next 5 years, right? So all of these two features help you with compliance. If you have some compliance requirements for the application, for the use case that you have, it's very important that you look at the product, the object storage solution that you are going to use supports worm, supports hashing or integrity seals. And obviously, please keep an audit trail. That is very useful. In our system, we basically keep everything, so we can know that this specific user deletes or deleted this packet or deleted this file at this specific time, right? Or this specific IP address accesses the cluster and retrieve this information or retrieve these files. So make sure that you keep an audit trail of all the operations that are happening from the client side to the object storage platform.
Can you talk a little bit about what happens if an object fails a hash or an integrity check?
Yeah, basically what's going to happen is if someone modify the file at some point, you will see that the hash doesn't match. What you want to do probably there on this scenario is to have like a versioning, for instance, object versioning enabled on the cluster, so you can go back to and retrieve a previous version of the object that has not been modified. Right. So that could be a possibility on this kind of scenarios whereby you want to make sure that that you get the same object that you uploaded 2 months ago, right? And the next step, like I said, will be just use worm. If you use worm, no one can modify that file, right? Not even if they have the proper permissions.
Presumably, too, depending on the data protection scheme, you have either other replicas or other erasure coding segments to reconstitute the correct object, right?
Yeah. So yeah, we can talk. Let's talk a little bit about the data protection scheme that we see in the object storage platform. This is something that again needs to be planned. We just introduced this topic a little bit earlier in the webinar. In the object storage world, we have kind of two ways of protecting the data to make sure that the data is safe. One being replication, and replication is having like the same object stored on a different server in the cluster. So if a server goes down, you have that object safe on a different one, right? On a different server, on a different piece of hardware. You can have, in our system, for instance, you can have up to 16 replicas of the same object stored in the cluster. The other option could be erasure coding. Erasure coding, what it does is basically slices the data into data segments and parity segments, right? So, and spread those segments across multiple servers in the cluster. The bright side of the thing that you get with erasure coding is that you get the same level of protection that you get with replication, but with less disk footprint on the system. You have the example on the screen right now. For instance, if I go with 1 million objects, 1 megabyte per object, and 2 replicas, that's basically 2 terabytes. If I do the same, but with 5.2 erasure coding, that's 1.4 terabytes. So if I am using 5.2 scheme for erasure coding, that's 5 segments of data, 2 segments of parity. I can withstand 2 simultaneous failure on my environment and being able to retrieve that file. And I am going down on the amount of space that I'm going to use on the system. It's just 40% overhead on this example, right? And you have another one that is 33% overhead on the right-hand side with 6.2 erasure coding. So that needs to be planned as well. What kind of level of protection do you want to have And I can go further on that, because some object storage platform relies on rings. That's the architecture of the storage nodes that they are on the back end. Rings are a set of servers that are provisioned for a specific erasure coding or replication scheme, right? So, for instance, if I want to use in some object storage solutions, if I want to use 4.2 erasure coding, I will have to use these 6 servers that I have provisioned specifically for 4.2 erasure coding. If I want to use 9.3 erasure coding, I will have a different set of servers to provide the 9.3 erasure coding scheme protection. So it's a way of segmenting the data. In Swarm, we do the opposite, actually. We can set multiple protection schemes on different logical levels. So you can have an endpoint or even a bucket that has 5.2 erasure coding and a different bucket with another bucket with 4.2 erasure coding, 9.3 erasure coding, whatever you have, and actually have the ability to mix both replication and erasure coding. For instance, if the file is less than 10 megabytes, then use 2 replicas. If the file is greater than 10 megabytes, just go with 4.2 erasure coding, right? So that's up to you, the way that you want to configure a lesson Swarm. But just think that you have to have the appropriate resources, hardware resources, to keep with that level of protection that you want to have. Like I said before, if you have a 3-server cluster, don't go with 9.3 or 9.2 erasure coding, because doesn't make much sense. You don't really have enough servers to go with that erasure coding scheme, right? So in all of this that we are saying, it's also important to note, at least from the Corringo perspective, that we will help you to architect your own solution, right? So it's not like, okay, I'm going to send you or to sell you a license for Corringo Swarm of 100 terabytes and just leave it there. Now we will help you to understand your workflows, understand your requirements, and then we will put together a solution that will match everything, all your expectations regarding performance, regarding data protection, data durability, and obviously, that matches your specific workflow as well.
I mean, systems that are kind of sold using usable terabytes are really flexible with this, right? You can kind of dial in the protection you need.
Yeah, and that's really, really important, that you have the flexibility to set the protection scheme that you want to have for very specific use cases. And in our system, we don't have a ring architecture. In our system, all the nodes perform all functions. So it means that, if you have a 100-node type of cluster, the 100 nodes can do any kind of erasure coding, any kind of replication scheme that you want to do, right? So, and you get the performance of 100 nodes, providing you the data, or when you upload the data, you are uploading to a 100-node cluster. So you are not uploading data to silos that has a specific set of servers for a specific protection scheme. So I think that's important, especially when you're scaling out and adding servers and adding more capacity. So once we have the data protection scheme, I think it's important to think about the data recovery scenarios. How automatic, that's the first question that you have on the screen, how automatic is recovery? Do you have to go manually and click like on a button that says rebuild data or rebuild disk? If that's the case, I will tell you that's not a good system, right? Like we discussed before, the object storage platform should be able to, first of all, anticipate that a disk is going to fail, if possible. But most important is that it has to have the ability to rebuild the data without having an administrator clicking on a button or making sure that the data is rebuilt, right? Also, is data fully accessible during the recovery process? Sometimes if you have to recover data, you have to bring down an entire server in some object storage solutions, right? So that's kind of that's kind of too much, let's say. So it will be affecting your service if you are just bringing down servers to replace just a broken disk. Or even worse, if you are, let's say, this is about data recovering, but let's say that you are upgrading your cluster to a newer version. Do we have the ability to do, this upgrade on production? Or do I have to stop my production to upgrade the cluster? So that kind of goes to the same point of the cluster should be accessible at all times. And that comes with a very, careful planning on the data protection schemes on the hardware that you want to use, and so on. Yeah, and also, like they said, the third point says about if I am adding hardware, do I have to stop my cluster to add a new node? That doesn't sound like a good plan, right? So we should have the ability to just, connect a new node, just put it into the rack, connect the power cable, connect the network cable, fire it up, and the node will be automatically joining the cluster. That's what we do in Swarm, actually. So in the end, the thing is when we are increasing the amount of servers, everything is online, and you are able to access the cluster wherever you want. And actually, the same goes if you are going down on the capacity, or for instance, if you are renewing your hardware. If you want to get rid of old servers with small disk drives, it's important that your object storage system is able to keep up to make sure that you can do that even with clients accessing the cluster, right, and applications. So I think that's pretty much it. I don't know if you have any further questions that we can answer for you.
I think that's about it. Thanks very much, Jose. Thanks everyone for joining us. To keep up with Corringo, follow us on Twitter or LinkedIn. And if you have additional questions or would like to schedule a custom demo, please email us at info@corringo.com. Thanks, Jose, and thanks everyone for joining us.
Thank you so much.